Okay, so up to the solution is completed. So let's enter into the CFD post. So just double tap on the results. Okay, so now the model is getting imported. We are interested to find so many factors like wall y plus and then skin coefficients like that. So first of all, so all the results now we are looking for in the format of charts. Okay, so to create any charts in CFD post, obviously you need a lines. Okay, so how can I create the lines? So in the previous cases also we have created some lines. So in this case it's an axisymmetric problem. Fluid flows in a turbulent flow through a pipe. So we have created so many lines at the axis, at the wall region, at the outlet. To create any lines, go to the locations. You'll have the option called a line. Just choose that. Try to enter any name. So I will give the name as, so the first line is at the wall region, pipe wall, and click on OK. Like always, it asks you for the coordinates. It's an absolute coordinate values. I'll enter the value of 0 and 0.1, 0.1 and 0. So point number 2, 8, 0.1 and 0. So I'll give the sample as 100 and click on apply. You may be visible an yellow color indication. So that means the line we have created, pipe wall, is created in this region. So I'll zoom in, I'll show you that line. See, yellow color line is actually created over here. Okay, fine. So remaining, we need to create 2 more lines at the bottom region and at the outlet also. So the same procedure, lines, I'll name it as a pipe center line, just because it's located at the center, right? So pipe center line. Okay, and give the factor. So the first point is 0, 0, 0 and the second point is 8, 0, 0. I'll give the sample as 100 and click on apply. Okay, now we'll have a line from this point to this point. Okay, so similarly I need a line over here also. So in this region. Okay, so to create that, go to location, again click on line. I'll name it as a pipe outlet. Pipe outlet and say OK. I'll give the name as, point as 8, 0, 0 and 8. So the length from here to here is a 0.1 mm, 0.1 meters. So I'll give a factor in Y. Okay, good. So once it is done, the sample is obviously 100 and click on apply. Yes, now we have a line over here also. Okay, so the next thing is to create the chart. So first we'll find wall y plus. Wall y plus. So we already discussed about wall y plus and why we find the wall y plus in our previous sessions also. If you have still any doubts in the wall y plus, so just refer or just study some theories which is related to wall y plus. It's very important to find wall y plus in any turbulence flow, or in some laminar conditions also we studied about the wall y plus. So it's just more related to the velocity changes nearby the walls of the fluid. Okay. So to create any charts, click on this icon. So here you'll have an icon to create charts. It asks you for the name. So I'm interested to find the wall y plus. Wall y plus and say click on OK. So go to the data series and change the name as a y plus. Okay, so once you define the name, try to change the location. So obviously the wall y plus we find nearby the wall, so choose the pipe wall region and go to the x-axis and change the variable to x. So and go to the y-axis and change the variable to y plus, that is wall y plus. So as you define the x and y axis, just click on apply. Okay, so as soon as you click on apply, you will get a wall y plus region chart. Okay, so the next we are interested to find the center line velocity. So the velocity at the center line. Okay, so obviously we know that at center line we have the maximum velocity. So just click on this chart again and name it as a center line velocity. And say click on OK. So change the name as center line velocity. So once you define that, the region, the location, you know that is pipe center line, and go to the x-axis, can choose in x for x also, and for y you can choose velocity u also. So once you choose that, just click on apply. So you will get a velocity chart at the center line. Okay, fine. So the next thing we already added as a additional parameters, that is coefficient of skin friction. So just click on the chart again and I'll give the name as coefficient of skin friction. So click on OK and I will name the factor as skin friction coefficient, and the location is obviously the wall. So nearby the wall we are interested to find the skin friction coefficient, and in X tab I'll choose x-axis, and in y obviously the variable is skin friction coefficient. So unless you don't add this skin friction coefficient in Fluent module, it is not available over here. So only you can get this parameters or the variable when you added that thing as an additional parameter. So okay, I'll choose the skin friction coefficient and say click on apply. So as soon as click on apply, you'll get a chart like this. So you can see the fully developed value as 0.008 over in this chart. So we call it as a Moody chart. So the next thing we are interested to find the velocity profile at the outlet. So or else you can say it as a outlet velocity. So I'll name it as a outlet velocity. And say click on OK. Here also you can change the name as outlet velocity or velocity. So the location you have to choose, so obviously the pipe outlet. So the x variable is, so I'll choose x as y and y variable as, okay, so y variable as y and in x variable is velocity. So once you define these things and click on apply, okay, so you'll get a profile like this, so which shows the velocity changes in the outlet. Okay, So the axial velocity is maximum at the center line and 0 at the wall. So it shows that there is no slipping boundary conditions over in the viscous flow. Fine. So the next thing is we can't directly or we can't blindly believe these results, because we only do this analysis for a one meshes, right? So we need to verify the results for the mesh variation. So how can I do that? You can simply compare the results of two different sets of analysis in the CFD post environment. So for that, so if you want to view the previously created chart in the report tab, so the below region, the wall y plus, and then center line velocity, and then coefficient of skin friction, so everything is placed over here. So just double tap on the result to view the chart. Okay, so how can I compare this? So just close this thing. So once you close that, we have the completed turbulent flow analysis set. So I want to make a copy of this analysis. It's very simple, just right click. So you'll have an option to duplicate this same system. So just duplicate it. It will take some time to duplicate the entire system. Okay, so once the duplicate is created, so I'll change the parameter 3x turbulent flow or else 3x mesh. Okay, so 2x mesh turbulent flow. So you can name anything. So for the difference, I will name it as a 2x mesh turbulent. So what I will do here is I can change the mesh configuration as the double the time of the previous mesh. So in the previous case, we use the configuration. So we have a pipe like this. So in the set, it is divided into 100 segments, and this region, that is diametral region or a radial region, we split it as 3 segments by using edge sizing. But this time I'll change this configuration to 60. Okay, so instead of giving 30, I will change it to 60. So 60 cross 100 is used for this region, and that means while comparing to the previous cases, we have more fine meshes. So that means you'll get a more accuracy in the system. Like always, you can compare the both results on a single system. Fine. So first I will double tap the mesh. I don't change any other things like the boundary conditions. I don't do any disturbance at all. So I only change the mesh configurations at all. So once the mechanical or the meshing environment is opened, so all you need to do here is just go to the meshing, choose the sizing. So I don't want to disturb this 100 revisions. Go to the edge sizing 2. Now it has the number of 30. I'll change to 60. So once the 60 is changed, you don't need to change the biasing factor. It remains 10, and just right click and say generate mesh. Okay. So you'll get a more proper mesh than the previous case. So now we have 60 segments of splittings. So I'll close the system. So you don't need to open the Fluent environment. So all I need to do here is just update the mesh from here itself. Right click and say update. Okay, so once it is updated, just click on the setup, right click and say generate. So it will update the mesh in Fluent environment and try to resolve the problem once again. So at the bottom you will get the informations, the loading mesh and the model information like that. Usually it takes some time to process the entire results. Okay, so once you get the green color tick icon, so just click on the solution, right click and say update. Now the solution is initiated to update the things. Now the solving part is initiated. Okay. So now I get a green color tick over the solution. So you don't need to right click and say generate the results. So because I want to compare the results of both systems. So that is why, so what I'm going to do here is I just drag and drop the results to this results environment, or else you can just click over the solution and drag and drop it to transfer to this results. Now what happened here is this solution is also transferred to this result, and this solution is also transferred to this results. So now you can compare the both solutions of the 30 cross, so this is 30 cross 100, okay, I'll make it as a text for better understanding. So this is 30 cross 100 mesh, and this system stands for 60 cross 100 mesh. Okay, so you can use these things, I can compare these things. So it's very simple, just double tap on the results. Now the results is get updated. Okay, so all you need to do here is we already calculate the wall y plus and then center line velocity and everything is already calculated. So all you need to just double tap on these things. So you can clearly understand how the mesh, I mean wall y pluses differ according to the mesh sizing, and so only the wall y plus will differ because you know that wall plus is a factor of how the velocity is changes nearby the region. If you have a more number of nodes and elements nearby the wall region, you will get a more number of accuracy. So apart from that, the centerline velocity is remaining same as it is in the previous cases, and the coefficient of skin friction has some little bit of changes, but not too much of things. So the green color line, I mean the blue color line and the red color line, which indicates the two different things. So here also you'll have the difference. The skin coefficient for X mesh turbulent flow is in the color of red, and the skin friction coefficient of turbulent flow is in the format of blue color. Okay, and double tap on the outlet velocity also, which is remaining same, follows the same path. Okay, so this is how you can compare the results of both things. Okay, so that is all for this session. So we completed the turbulent flow analysis. In our upcoming session we will discuss about the periodic flow in CFD model. Okay, thank you.